Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Domain 4 of the AWS Certified Cloud Practitioner exam shifts our focus from technology to the financial and operational dimensions of the cloud. This domain asks you to understand how AWS pricing works, how to control and monitor costs, and how to align your support plan with the criticality of your workloads. It's not enough to know how to deploy services. You also need to know how to pay for them intelligently and manage them responsibly. The essence of this domain is financial literacy for cloud operations. When you understand the pricing models, the cost controls, and the support tiers, you can design architectures that are not only resilient and secure, but also cost-efficient and well-governed. At the heart of AWS pricing is the principle of pay-as-you-go, but this principle branches into different commitment models. On-demand instances provide maximum flexibility. You pay only when you run resources, with no long-term commitments. Reserved instances, or RIs, provide significant discounts in exchange for steady, predictable usage. Spot instances, on the other hand, offer steep discounts for workloads that can tolerate interruptions. These three form a spectrum: on-demand for uncertainty, RIs for predictability, and spot for opportunistic, fault-tolerant tasks. For exam purposes, any question about uncertain workloads means on-demand, while steady baseline means RI or savings plans, and interruption-tolerant signals spot. Savings plans are the modern evolution of RIs, offering flexible discounts across compute services. Compute savings plans cover EC2, Fargate, and Lambda, giving the broadest coverage but slightly smaller discounts. EC2 instance savings plans are narrower, tied to specific families, but offer deeper savings. The trade-off is between flexibility and specificity. For the exam, if you see mixed compute services, the answer is Compute SP. If you see long-term EC2 family workloads, the answer is EC2 Instance SP. Together, these options highlight how AWS allows you to align pricing with your workload stability. One of the most overlooked cost factors is data transfer pricing. Data coming into AWS is free, but data going out, whether to the internet, across regions, or even across availability zones, carries charges. Internet egress is charged per gigabyte. Cross-region replication adds cost, and cross-AZ traffic can quietly inflate bills. For the exam, phrases like cross-region replication or internet egress are red flags pointing to transfer costs. This underscores a key AWS principle: the further data travels, the more it costs. Awareness of these patterns helps you design smarter architectures that minimize unnecessary transfers. Network services like NAT gateways, VPC endpoints, and load balancers also bring their own cost considerations. NAT gateways charge both hourly and per gigabyte, making them expensive if used heavily. Interface endpoints also charge hourly plus per gigabyte, while gateway endpoints, like those for S3, are free to use. Load balancers count traffic as part of load balancer capacity units, so high throughput can raise costs. For the exam, if you see a question about hidden costs from networking components, these are the culprits. The lesson is that even internal architecture choices have financial impact. Storage costs in AWS rest on three pillars: capacity, requests, and retrieval. Storing a terabyte in S3 has a base cost, but every GET, PUT, or list request also has a price. Glacier adds retrieval costs for archived data. Lifecycle policies are essential to control costs, automatically transitioning data to cheaper classes when access declines. On the exam, scenarios mentioning archival or infrequently accessed data point to lifecycle management. The storage model is simple. You pay for how much you keep, how often you access it, and how long it takes to retrieve it. Serverless services like Lambda use a different model, requests multiplied by duration. Instead of paying for idle servers, you pay only for execution time. This is cost-efficient for spiky, unpredictable workloads, but long-running tasks can add up quickly. Containers, by contrast, charge based on the number of tasks or pods and their runtime hours. On the exam, cues like pay per request point to Lambda, while pay per task points to ECS or EKS. These differences illustrate AWS's broader theme: align pricing with actual consumption, not static infrastructure. The AWS Pricing Calculator is a planning tool to forecast costs before launching workloads. It asks you to enter inputs like vCPUs, storage size, requests, and data transfer, then outputs an estimate. The exam does not test exact numbers, but wants you to know which inputs matter most: instance hours, data transfer, and storage volume. The key takeaway is that the calculator is about structure and foresight, not precise billing guarantees. It is a way to model scenarios and show how changes in design affect overall costs. AWS Cost Explorer goes deeper, analyzing actual usage and spend trends. It can filter by service, group by region, and show utilization patterns. It also provides right-sizing recommendations for EC2, suggesting smaller instance types or commitment models. Exam cues like analyze spend trends or identify underutilized instances point to Cost Explorer. It is the microscope for financial data, turning raw usage into actionable insights. Cost Explorer helps you move from estimating costs to optimizing them. AWS Budgets provide the proactive side of governance. They let you set thresholds for cost or usage and send alerts when spending approaches or exceeds them. Budgets can also track reserved instance or savings plan utilization. On the exam, the phrase set guardrails or send alerts maps directly to budgets. They are not about deep analysis, that's Cost Explorer, but about staying on track and preventing surprises. Together, Budgets and Explorer form a pair. One prevents drift, the other explains it. AWS organizations and consolidated billing unify costs across multiple accounts. Instead of dozens of bills, there's one. Commitments like RIs and savings plans are shared across accounts, maximizing utilization. Exam scenarios that mention single bill or shared discounts point directly to organizations. Cost allocation tags and cost categories build on this by grouping spend into business-friendly categories like marketing or Team A. The takeaway is that organizations give you central financial efficiency while still allowing decentralized account structures. The Cost and Usage Report (CUR) provides the deepest visibility with line item data for every resource and cost. It feeds into analytics tools like Athena or QuickSight for custom dashboards. Exam cues like Most Detailed Billing Report or BI Integration Map to QR. It is the raw dataset for financial governance, enabling advanced showback, chargeback, and optimization at scale. Finally, support plans round out cost governance. Basic covers billing and documentation only. Developer adds business hours technical guidance. Business introduces 24x7 technical support and full trusted advisor checks. Enterprise and Enterprise on-ramp add technical account managers, concierge services, and proactive reviews. Exam cues are simple: developer for sandbox, business for production, enterprise for mission-critical workloads. Support is about aligning plan level to workload importance. The cultural thread running through Domain 4 is FinOps, the practice of measuring, optimizing, and governing costs as an ongoing cadence. AWS provides the tools, but organizations must embed cost awareness into their operations. The exam may hint at this with continuous review of costs or align finance with engineering. The answer is always to apply a FinOps loop, ensuring costs are managed just like security or performance. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Egress control is another core practice. The further data travels, the more it costs. The best design is to put compute close to the data, not the other way around. Keep analytics near S3 buckets, cache at the edge with CloudFront, and minimize cross-region replication unless required. On the exam, the words reduce egress or minimize cross-region transfers point to this principle. The cultural shift is to treat every byte as a budget item. Local, private paths are cheaper. Public and distant paths are expensive. Architects who embed this thinking into their designs avoid one of the most common sources of surprise bills. Cross-AZ hygiene is another hidden cost saver. Many workloads spread across availability zones for resilience, but careless designs create constant chatter between AZs, racking up charges. The best practice is to align tiers within zones and replicate only what is necessary for failover. For example, place application servers and their paired database in the same AZ, then replicate asynchronously to another AZ for redundancy. On the exam, scenarios mentioning reduce cross-AZ chatter are pointing to this hygiene. The rule is not to avoid multi-AZ, but to design with awareness of when and why data must cross those boundaries. Right-sizing is one of the easiest yet most powerful cost levers. AWS Cost Explorer can show idle hours, underutilized instances, or oversized storage volumes. Adjusting an instance from extra large to large or moving data from expensive storage to cheaper classes can yield immediate savings without affecting performance. On the exam, the cue is optimize instance size or reduce idle capacity. The correct answer is always right-sizing. In practice, right-sizing is an ongoing activity. Cloud workloads rarely stay perfectly aligned to their initial resource selections. Metrics-driven adjustments keep costs efficient over time. Storage lifecycle policies are the natural extension of right-sizing for data. Hot data belongs in standard storage, warm data can live in standard IA, and archival data belongs in Glacier. Automating transitions with lifecycle rules ensures data naturally moves to cheaper tiers as its value declines. The exam often signals this with long-term backups or infrequently accessed data. The best answer is to apply lifecycle transitions. This practice ties cost to data value, ensuring you don't pay high rates for bytes that sit untouched. Spot readiness deserves attention as well. Spot instances are powerful tools, but they demand resilient architectures. Stateless tiers, checkpoints, and queues make workloads interruption tolerant. For example, a batch job writing progress to S3 can resume even if spot capacity disappears. On the exam, phrases like quote, can tolerate interruption or stateless front end point to spot. The key is not just choosing spot, but designing with spot in mind. Without checkpoints or queues, spot savings turn into fragility. With them, spot becomes one of AWS's strongest cost levers. Comparing savings plans and reserved instances highlights a recurring theme: flexibility versus specificity. RIs offer deeper discounts but require you to choose a specific family and region. Savings plans offer broader coverage across EC2, Fargate, and Lambda, but with slightly less savings. On the exam, cues like flexible across compute services point to savings plans, while consistent EC2 usage in one family points to RIs. Both serve the same purpose: discounting steady usage, but they differ in scope. Knowing which applies to a scenario is an exam-ready skill. Budgets create guardrails. Owner-level budgets ensure accountability, sending alerts when spend or usage crosses thresholds. This empowers teams to own their costs instead of leaving finance to chase them after the fact. On the exam, phrases like send alerts when spend exceeds $X point to budgets. They are not analytical tools, that's Cost Explorer, but alarms. In practice, budgets become part of the operating rhythm. Each team receives alerts, investigates causes, and adjusts usage. It creates a culture where cost is shared responsibility. Forecasting ensures you plan for reality, not just averages. Seasonal campaigns, product launches, and cyclical usage all create spikes that forecasts must account for. Budgets in Cost Explorer can be configured to recognize patterns, showing expected versus actual spend. The exam may phrase this as account for seasonal variation, The right answer is always forecasting. This demonstrates that cloud cost management is forward-looking, not reactive. Amortized cost views add financial clarity. By spreading the upfront cost of RIs or savings plans over their term, you see the effective hourly rate. This prevents distortions in month-to-month comparisons. On the exam, cues like Show Effective Rate of RIs point to amortized cost views in Cost Explorer. The principle is that commitments only make sense when viewed over time, not as one-time charges. This is how finance and engineering speak the same language about cost. Showback and chargeback close the governance loop. By using tags, accounts, and cost categories, organizations can allocate costs back to the teams that incurred them. Showback makes costs visible, while chargeback makes them actionable by assigning responsibility. On the exam, allocate spend to departments or cost accountability across teams points to this mechanism. This reinforces AWS's message that cloud finance is a team sport, requiring visibility and accountability across the organization. Support ROI is another dimension. Higher-tier plans like Enterprise deliver value beyond break-fix, including TAM guidance, launch reviews, and proactive governance. The exam often frames this as mission-critical workloads needing roadmaps and governance. The correct plan is Enterprise. The ROI lens helps you see that support is not a sunk cost, but a form of insurance and expertise, offsetting risk and accelerating adoption. Common pitfalls include unused commitments, surprise egress charges, and missing tags. These appear frequently as exam distractors. The safe rule is to avoid answers that describe wasteful practices. For example, purchase large RIs before workload patterns are known is a trap. The correct approach is always to measure, commit only to steady baselines, and tag everything. Recognizing these pitfalls ensures you eliminate bad answers quickly and confidently. The exam strategy for Domain 4 boils down to mapping scenario keywords to the right tool or plan. Unpredictable usage means on-demand. Steady-state workload means RI or savings plan. Interruption tolerant means spot. Cross-region replication means transfer cost. Send alerts means budgets. Analyze trends means Cost Explorer. These mappings are not just test tricks. They mirror how you'll think in practice. Cloud design is about translating requirements into the right AWS service or cost tool. The final readiness check is cultural, embedding cost awareness into operations. Teams must treat cost as a design factor alongside performance, reliability, and security. AWS gives you the tools, but only culture ensures they are used consistently. From commitments to budgets, from tagging to forecasting, financial discipline becomes part of how systems are built and run. For the exam, this is the underlying theme of Domain 4. Cost-aware design is not optional, it is part of being cloud-ready. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.